My name is Abir Hassan and
My name is Muhammad Amiriman and we are doing Lab 3.
Lab 3 from Group 6. Part 1 was done by me, and part 1 we were given active low 7 segment display where the output was supposed to be given from the input, which was a switch from a 4-bit switch. So the ports being used by the output are C0, 1, 2, 3, 4, 5 and 7. The reason for not using C6 is because the C6 from our MCU was not working properly. And for the inputs, for the switches 0, D0, 1, 2 and 3 were used. And the input was connected to a ground and a VCC along with a SIP resistor, because as we all know that it needs to know when it is high and when it is low. Talking about the active low or active high of the switch is not important, as we are the one that can control it. So for the 7 segment display, the comms were connected to a resistor, which was then connected to the VCC. There are 2 comms from 7 segment display which were connected to the resistor and then to the 3.3 volts supply from the MCU. And now I will demonstrate on the digits according to this input. So over here, as you will all see, that I'll change the inputs for the switch, and accordingly the output on the 7 segment will change. We will be talking about the code later into the video. Okay. Anyways, for 0, all these inputs are 0. In order to get a 1, the first bit is set to 1 and the rest are 0. And for displaying 2, the second was done to 1, a high was given to 1, due to which it shows a 2. And for a 3 and for a 4, for a 5, for a 6, for a 7, for an 8, for an 8 and for a 9. And we coded our program in such a way that if any input which is more than 9, it displays a dash in order to tell that it cannot display, as it's just a single 7 segment display. For the code for 7 segment display is simply we initially defined all the LEDs as LED 0, 1, 2, 3, 4, 5, 6, ports 0, 1, 2, 3, 4, 5, 7. Switch was initialized as a 0F, which is 111, but this is active low, so basically it was cleared. Initialization, a clock was given to port C and a port D. Mux, DSC, P and pull strength was done to port 0, 1, 2, 3, 4, 5, 7. And then accordingly for port D, PCR, Mux and PE was done, as these are the inputs. Then GPIO PDDR was done for all the LEDs. We cleared all, we will set all the LEDs, and then PDDR for the input switch. Going on to the first part of the, there are 2 basic functions that we used. One is set digit and the other is read input. So if we go to the main, we just call the read input function infinity times, and what it does is basically if you go to the read input, it checks the value. First is PDIR and the switch and the input for that. If it is 0, 0, then it calls set digit 0, and if it is 0, 1, then it calls set digit 1, and accordingly for all the ports. And if else, else is just calls digit 10, which will be shown now. And for the set digit function, basically if LED number is 0, which was given from which was actually given to us from here, what we do is we simply set the values of the LEDs, all of them, to 1, basically yet again active low, and then we clear the LEDs that we need to turn on. So in this case 3F was basically turned on, and clearing means in this case for active low means that we turn on the LEDs. So for 0, 3F was done. From the video, as it can be seen on the table here, that if the input is 0, 0, 0, 0, it will represent the decimal 0, and the ports LED 0, LED 0, 1, 2, 3, 4, 5 is basically turned off, and C7 and C6 is turned on, which due to which we get a value of 3F in the hexadecimal, which we used in our code for representing a 0. And for 1, accordingly, the LEDs were cleared, and we get a hexa value of 069B8F, and accordingly, which was then put into the code. But before doing everything, we do set the values of the LEDs to 00FF, which is 1111, basically turning off LEDs, and then it goes back to the main function. When it gets the read input, it goes to the read input function, gets the value, which set digit is it going to call, get to the set digit value, check which number of LED number it is, and then accordingly clear those values, and this runs infinity time.
For the second part, which is the ADC, so at first we have to include all the required thing, and we have to define what we are using. So for the first part, we have to initialize the ADC, and we have to enable the clock like this, and these are all requirements that is needed in order to initialize the ADC. And after that, we have to do ADC conversion. Okay, so from the microcontroller is basically taking value from light sensor and do analog to digital conversion, which means take the value of a light wave and convert it into a binary 1010, which means we can use the value from the light sensor in our main. We call in the function of clock initialize, which is the first one, and then we have to do the conversion. So as you can see, we call the function of do ADC conversion here, and we put it inside result. So from this result here is the binary result of the conversion of light sensor from analog to digital. So this is a binary value. So from here, inside here, we do a simple conversion which we can interpret, which means we use the value, we times with this formula, and we print it up on our kitty. You can see this is showing the integer value of the result, and this shows the decimal value of the result. So moving down, after printing this printf, we have a short delay here, and basically it's just like this. It's a very simple program. So right now we have this program running at background, so I can show you how. So this is our board. So right now it's running at around 3.1 without any disturbance. So if let's say you cover the light sensor using a finger, it will increase value to 3.37, which is the maximum value. And let's say if you shine light on it, as you can see, shine light on it, it will become lower, 0.26 to 0.27. So that's all for ADC part. Thank you so much. I think part 3 is actually just a combination of part 1 and part 2. So for the part 1, actually we have to take the value from the light sensor and change it into a value, and channel the output from the ADC to the input of the 7-segment display. So firstly, we have to define as what we did in part 1. We have to define all the LED first, and then initialize all the digit exactly the same as part 1, and then we have the set digit. Okay, so we copy paste the set digit because it doesn't affect anything on our outcome of the project. So if you see here, the only thing we change is the read input from part 1. So basically is we are taking the value, the output of the ADC, and we interpret it into limits. So I did some try and error, and I found out that if you shine light onto the ADC, it will have a value of 239, which is the maximum light intensity, and when you cover the light sensor, it will become 1023. This is the lowest value produced by the ADC. So by using this value, we can find the difference, and we can set limits, an increment for each limits. So if you see here, so if let's say, so we are taking the output of the ADC result. So if the output of the ADC says 1023, which is the minimum meaning is the dimmest doesn't have any light, we are setting digit equal to 0, which activate a number 0 on the 7-segment display corresponding. So it's actually the same. So if let's say the value is lower than 1023, it will become set digit 1 and set digit 2 and so on. So if it is smaller than 239, which is the maximum intensity of light shine on the board, it will produce set digit 9, which is the maximum. So the ADC part is actually basically the same. The initializing part is exactly the same. Just copy paste everything except for the main part. For the main part, we have to do a bit of change. We have to, of course, add in the initialized digit. Okay, and we have to do a bit of read input. Okay, our read input for the 7-segment display is from the result, which means the output of the ADC, if you can see here. So we are using the output of the ADC and we interpret the data. So we have a running board, running part 3 right now. So if you can see here, so we are using the ambient light. So the ambient light level is around 1 or 2. So let's say if I shine light on it, it will increase the value until 9, which is the maximum. So if I pull my handphone slowly, it will decrease from 9 to slowly to 2 and to 1. And this shows that our project is working fine. So that's all. Thank you so much.